In the previous video, we spoke about random errors. These are errors that don't lead to bias, but they do lead to lack of precision. In this video, we're going to talk about systematic errors which do lead to bias. And these come, first of all, as a result of selection biases, and secondly, as a result of information biases. We use this diagram just to illustrate what we mean by selection bias. You'll see that in this diagram there are all sorts of different kinds of people, some represented by triangles, some by little cylinders, and so on. And they're all different colors. And if you choose a sample that consists only of little blue triangles, it will no longer be representative of the whole people in the study population. And that may give rise to bias due to the fact that your sample was not selected at random and is not representative. So what selection bias is, it's a systematic error in the selection of participants into your study, which is going to give rise to bias. And it's more likely to happen if you don't have a good understanding of the study population in terms of who, where, and when, and how to access this population to make sure that your sample is representative and not biased. So this makes very strong point here that you need to really define your study population very, very carefully before you even start to think about developing a valid sampling frame or strategy and going ahead with sample selection. Here are some rather glaring examples of selection bias. For example, you may decide only to use landline telephone surveys, and then you would only access people who have landlines and who are not at home. If you're phoning the house, for example, you'd end up with a sample consisting of elderly and unemployed people and people who were in a socioeconomic state that they would be able to afford to have a landline telephone. The healthy worker effect is a well-known one. This is where people who become sick at work leave work. So then when you go and sample the people at work, you don't find anybody who's prone to that occupational illness. So that gives rise to selection bias as well. And the last one is very serious pitfall. You may recruit your patients from a referral hospital, and they may come from all over the country, and then you go and choose your controls from the neighborhood of that hospital or from the accident and emergency department, and the controls therefore only come from one part of the country, and they may not be comparable to the cases. So this again can give rise to selection bias. Now, having dealt with selection bias, we're going to talk about information bias. So you might have selected an appropriate sample, so there's no sampling bias, but you now have a systematic error in the collection of data or information from your unbiased sample, and that may give rise to bias. You may sample correctly, but you don't get the correct information because the people in your sample, you're not getting the right information from them. So in this diagram, you see that now your sample is actually representative. You've got people of all different kinds in your study population included in your sample. The problem now arises that maybe you're not going to get the correct information from your unbiased sample. As an example, let's say you wanted to ask your unbiased sample of people questions about tuberculosis. And what if the people in your sample and actually in the whole population happen to think that TB is something shameful and they don't want to admit to it or admit to being on treatment? Obviously, then you're going to get the wrong information, misinformation from the people in this sample. The more sensitive the questions, the more likely it is that you might get incorrect information from your respondents. Here are some more Hypothetical examples where you might get incorrect information from an unbiased sample. For example, you might be questioning women about their obstetric history, and it's been shown that women who come from very poor and deprived environments may suffer many miscarriages over a lifetime and actually may not remember how many times they have had a miscarriage. You could also have observer bias. For example, in a randomized trial, it may be unblinded and the researcher may want to show a particular result or overlook certain side effects, and that can also lead to bias. And then you may have deficiency in the measurement tools. For example, the information that's written down in the medical records, especially in non-teaching hospitals, may be very, very inadequate and may also lead to bias due to omissions or even to incorrect statements written there, perhaps by a junior staff member. So here we have a list of things that you can do to avoid bias, whether it's sampling bias or information bias. You can go through these steps and these will minimize the likelihood that you're going to end up with biased information. So you have explicit protocols. Make sure your sample is random or representative and appropriate. Have very, very explicit, clear inclusion and exclusion criteria. Have procedures, standard operating procedures, to minimize non-response and loss to follow-up. Have clear diagnostic and exposure procedures. Ensure the tools are valid, reliable, standardized, and calibrated. Blind subjects and observers if at all possible, and train everybody well. Make sure everybody who's involved in collection of data is well trained. Use role play, for example, so that they can experience what it's like being at the other end of the questions. And then have frequent quality control checks throughout the sample selection and information collection process.